What are vector databases and how are they used in AI? Executive summary. Vector databases store data as mathematical vectors for similarity search. AI models create these vectors from text, images, or audio. The databases enable semantic search, recommendations, and RAG for large language models. They use special indexing for lightning-fast queries. Key applications include chatbots, fraud detection, and personalized media. While powerful, they demand high storage and computational resources. Hybrid approaches and multi-modal support represent the next evolution. Adoption is essential for modern AI systems. Article. Think about a traditional database. It stores information in neat tables. Each row is a record. Each column is a specific fact. You might have a table of customers. Columns include names, addresses, and phone numbers. You search for Smith and get exact matches. This works well for structured data. Now imagine searching for a meaning. You want a song that sounds happy. You need a picture similar to this one. You ask a question and want the most relevant answer. Traditional databases cannot handle these requests. They only understand exact values. They do not understand context or relationships. This is where vector databases come in. They store data as mathematical vectors. A vector is a list of numbers. Think of it as a point in space. A picture becomes a point. A sentence becomes a point. A video clip becomes a point. The database organizes these points. Similar items cluster together in space. Happy songs group in one area. Sad songs group in another. How do we create vectors? We use AI models to create vectors. These models are called embedding models. They convert raw data into numbers. A text embedding model reads a sentence. It outputs a vector with hundreds of numbers. An image model does the same for pictures. The model learns these numbers from training data. It understands patterns and meanings. The process is automatic. You feed the AI a piece of data. The AI returns a vector. This vector is a semantic fingerprint. It captures the essence of the data. Two similar sentences get similar fingerprints. The cat sat and a cat rested have close vectors. The numbers reflect this closeness. The distance between vectors measures similarity. What makes vector databases special? Vector databases are built for speed. They use special indexing techniques. These techniques allow fast nearest neighbor searches. You give the database a query vector. The database finds the closest vectors. It does not scan every single item. It uses algorithms like HNSW or IVF. These algorithms create hierarchical maps. They skip large areas of the space. This speed is crucial for AI applications. AI systems need real-time responses. A user asks a question. The system must find answers in milliseconds. Vector databases deliver this performance. They handle billions of vectors. They scale horizontally across servers. They also support updates. You can add new vectors easily. Key use case, semantic search. The most common use is semantic search. Traditional search matches keywords. You type car repair. You get pages with those exact words. You miss pages about auto maintenance. Semantic search understands the intent. It converts your query into a vector. It searches for similar meaning vectors. It returns the most conceptually relevant results. Companies use this for customer support. They embed all support tickets. They also embed all knowledge base articles. A new customer query becomes a vector. The database finds the most similar past tickets. It also finds the best articles. The system suggests solutions instantly. This reduces human workload. Use case, recommendation systems. Recommendation engines rely on vectors. Netflix recommends movies. Amazon recommends products. Spotify recommends songs. They all use vector databases. Each item gets a vector based on user behavior. Each user also gets a vector. The system finds items close to the user's vector. These items are likely to please the user. The database handles millions of users. It constantly updates vectors with new interactions. It performs similarity searches for every user. The system personalizes each experience. This drives engagement and sales. Vector databases make this scalable. They outperform traditional collaborative filtering. Use case, generative AI, and retrieval augmented generation, RAG. Large language models, LLMs, are powerful. They have a major flaw. They only know their training data. They cannot access private company data. They also hallucinate false facts. RAG solves this problem. RAG stands for Retrieval Augmented Generation. Here is how RAG works. You first split your documents into chunks. You embed each chunk into a vector. You store these vectors in a vector database. The user asks a question. You embed the question. You search the database for the most similar chunks. You retrieve the top few chunks. You pass these chunks to the LLM. The LLM generates an answer using this context. This grounds the LLM in real facts. The answer is accurate and current. The vector database acts as the long-term memory. The LLM acts as the reasoning engine. This combination powers chatbots, co-pilots, and research tools. Every major AI company uses this pattern. Use case, image, and video recognition. Vector databases excel with visual data. Security cameras generate millions of images. A vector database stores face embeddings. The system identifies a suspect quickly. It compares a new face vector to stored vectors. The search takes a fraction of a second. Retail stores use this for loss prevention. Medical imaging also benefits. Hospitals store X-ray and MRI vectors. A radiologist uploads a new scan. The database finds similar past cases. The system suggests possible diagnoses. This assists doctors in making decisions. The speed of vector search saves critical time. Use case, anomaly detection. Vector databases detect outliers. An anomaly is a vector far from others. Fraud detection systems use this. Normal transactions cluster together. Fraudulent transactions appear distant. The database flags these outliers instantly. Network security uses the same principle. Unusual network traffic patterns show up as distant vectors. The system alerts administrators immediately. Manufacturing monitors machine sensors. Each sensor reading becomes a vector. Normal operation forms a dense cluster. A failing machine produces a drifting vector. The database detects this drift early. This enables predictive maintenance. It reduces downtime and saves money. Technical operations inside the database. Vector databases perform three main operations. First, they index vectors for fast search. Second, they calculate distances between vectors. Third, they return the nearest neighbors. Distance metrics matter. Common metrics include cosine similarity and Euclidean distance. Cosine similarity measures the angle between vectors. Euclidean distance measures straight line distance. The choice depends on the embedding model. Most systems use cosine similarity for text. Indexing is the most complex part. The database builds a graph or a tree. HNSW, hierarchical navigable small world, is popular. It creates a multi-layer graph. The top layer has long connections. The bottom layer has short connections. The search starts at the top. It quickly narrows down to the bottom. This reduces search time from O of n to O of log n. Another technique is IVF, inverted file index. It partitions the vector space into cells. The search only checks the closest cells. This is very efficient for large data sets. Many databases combine HNSW and IVF. They offer configurable trade-offs between speed and accuracy. Popular vector databases. Several options exist today. Pinecone is a fully managed cloud service. It handles infrastructure automatically. Weaviate is open source and self-hostable. It includes built-in embedding models. Milvus is a high-performance open source system. It scales to billions of vectors. Chroma is a lightweight option for prototyping. QGrant offers a balance of features and speed. Each has different strengths. Pinecone excels in ease of use. Milvus excels in raw performance. Weaviate excels in integration with GraphQL. The choice depends on your use case. Startups often begin with Chroma. Enterprises often choose Pinecone or Milvus. Challenges and limitations. Vector databases are not perfect. They require significant computational power. Embedding large datasets takes time and GPU resources. The embeddings are also black boxes. You cannot easily explain why two items are similar. This lack of interpretability can be a problem. Storage costs are higher than traditional databases. Vectors are dense arrays of floats. A 768-dimensional vector uses about 3 kilobytes. A billion vectors use 3 terabytes. This requires expensive memory and SSD storage. Accuracy is also a concern. Nearest neighbor search is approximate. The database might miss the true closest vector. It sacrifices some accuracy for speed. Most applications accept this trade-off. You can tune parameters to balance precision and recall. The future of vector databases. The field is evolving rapidly. Researchers are developing better indexing methods. They are also creating more efficient embedding models. Hybrid search is gaining traction. This combines vector search with keyword search. It gives the best of both worlds. Multi-modal databases are emerging. They store vectors from text, images, and audio together. You can search across all modalities. You can ask, "Show me red cars and loud music." The database retrieves both types. This is the next frontier for AI. Vector databases will become standard infrastructure. Every AI application will rely on them. They are as fundamental as relational databases. They enable machines to understand meaning. They turn unstructured data into actionable knowledge. Summary of benefits. Let us recap the key advantages. Vector databases enable semantic understanding. They power real-time AI applications. They scale to massive datasets. They integrate seamlessly with generative models. They unlock insights from text, images, and audio. Companies gain a competitive edge. They provide better search experiences. They offer personalized recommendations. They build accurate chatbots. They detect fraud faster. All of this rests on vector database technology. Conclusion. Vector databases are a paradigm shift. They store data as points in a high-dimensional space. They find similar items by measuring distance. They make AI systems smarter and faster. They solve problems that traditional databases cannot touch. Every developer should understand them. Every business should consider adopting them. The technology is mature and accessible. Open source options lower the barrier to entry. Cloud services reduce operational overhead. The time to start is now. Anything you put into a cloud AI like ChatGPT is saved and probably used to train the model. You can protect your private data by running local AI models on your PC, Mac, or network. Applications and models are available for free. I can help you get up and running. Contact me for a free demo. You need a PC or Mac with Windows 10 or better. 8 gigabytes of memory, no GPU. More memory is better, but you can run 3B models on 8 gigabytes. They can be impressive. There are several free tools you can use for local AI, GPT-4ALL, LM Studio, Ollama, and anything LLM. I prefer GPT-4ALL and LM Studio. I have published more than 700 blogs on AI in the past 3 years. If you get value from these blogs, please join my Patreon as a member at the $2, $4, or $8 per month level. https://www.patreon.com/Steve Hovland. I have a new group on Facebook called Local AI by Steve Hovland.